Assalamu alaikum students, welcome to the world of physics. Now our topic is the third application of Gauss's law, which is electric field intensity between two oppositely charged parallel plates. I always use symbols for parallel and perpendicular and all other things. Now consider two oppositely charged parallel metal plates. Suppose this is the first metal plate having all positive charges residing on it. This is the first metal plate, and parallel to this plate is the second metal plate, say this one. As the first metal plate is totally positively charged, then the second metal plate is totally literally negatively charged. These two plates are there, which we have to discuss. The surface charge density on this plate is plus sigma, whereas the surface charge density on this plate is minus sigma, because it is literally positive, it is literally negative. These plates are assumed to be of infinite length in order to avoid the fringing field at the ends. So now under this condition, the field intensity will be uniform. Uniform means the lines of intensity will start from positive plate and move towards negative plate like this. So there will set up a uniform electric field between these two plates in this way. In this way, a uniform electric field will be set up between these two plates like this. Okay. Now we have to find out the electric field intensity at this point P. This point P is at this point. At this point we need to find out electric field intensity. So to find out electric field intensity at this point, we will make a box-like surface, Gaussian surface like this. This is a box-like Gaussian surface. I have made this surface with 4 sides. This is the Gaussian surface, and P is lying inside this Gaussian surface, and I need to find out the electric field intensity at this point by using Gauss's law, or according to Gauss's law, or by using Gauss's law. Just come on the equation of Gauss's law, that phi is equal to E dot delta A, and E dot delta A is equal to Q over epsilon naught. Instead of taking E dot delta A, I will take summation of E dot delta A. I have taken summation because there are a number of areas on which we need to find out electric field intensity, or we need to find out flux. Now first of all, I will take this area. Suppose this is side A, this is side B, this is side C, this is side D. I will take flux separately on all these sides, on side A, on side B, side C and side D. And as A is lying out of the field, that's why there will be no flux on A. I will write down E dot delta A. This is for A. Then plus E dot delta A. This is for B. Then plus E dot delta A. This is for side C. Then plus E dot delta A, this is for side D, and this should be equal to Q over epsilon naught. As I have told you that A is lying outside the Gaussian surface, that's why the flux through this Gaussian surface is equal to 0. What about side B? Side B is just parallel to the electric field. As B is just parallel to the electric field, that's why flux is again 0 through this surface. What about side C? Side C is the only surface through which lines are passing. If lines are passing, then flux is positive, and this is considerable side. Come on the side D. Through side D, again this side is lying parallel to the electric field intensity, that's why there will be no flux, no lines are passing through this line, again flux is 0. So the only considerable surface is third, which is, and flux passing through this surface is E dot delta A, which is equal to Q over epsilon naught in this way. Now again we will use over here surface charge density, and we will use the relationship that surface charge density is equal to charge per unit area. If surface charge density is equal to charge per unit area, then charge is equal to surface charge density multiplied by area. By using this equation in equation number 1. Say this is equation number 1 and I am using this equation in equation number 1. By using this equation in equation number 1, I will write down E dot del A is equal to, instead of Q, I will write down sigma A. Sigma A over epsilon naught. Instead of writing down del A, I will write only A, because del A and A means the same. Now as A is present on both the sides, by dividing A on both sides, A will be cancelled, and if A will be cancelled, then E will be equal to sigma over epsilon naught. This is the electric field intensity due to electric field intensity between two oppositely charged parallel metal plates. And I have to show over again a unit vector R, which is a unit vector and which shows the direction. So the electric field intensity between two oppositely charged parallel plates or metal plates is equal to sigma over epsilon naught multiplied by unit vector. Thank you very much.